this is general overview of what is the back pressure, why it is important to deal with it, and what it could cause. What we're going to do now, it's a little hands-on. This runs in Instruct. We're going to share one of the Instruct sessions by the end of this session. For now, we're going to show what we're doing here, to show how we can observe our telemetry pipeline and see if we are experiencing back pressure. I'm going to take a quick look to see if there are any questions yet while this loads. Thanks for. Okay, so what do we have here? Here we have a Fluent Bit container running, I think, the latest version from T3.2. We have a Grafana instance, a Prometheus server that will collect data from our pipeline, from our Fluent Bit. We have an HTTP server that we can use as the output side of our pipeline, and an additional terminal to handle our files. Okay. Is that all right? Yeah. Escape this. Okay, here's graph. And we're going to start with the first config. So we're going to create a config file. Should have now. Okay, so we can now run. Okay. Fluent Bit is running. This is quite simple configuration. Yeah, we are just printing a message to the standard output. We have the panels here. We don't have data yet and nothing on Prometheus, and we have here our server too. Okay, so what we're going to do is we're going to add a proper configuration to start looking into how back pressure looks like. Okay, so here we are generating some data, and we are trying to send it out to an output that is, of course, is not properly responding, right? The output server is actually down. It's not receiving any connections, so we can see the errors here. Okay, but there should be a better way to detect these kind of issues, right? And for that, we are going to enable the HTTP server so we can get the metrics from Fluent Bit. These two parameters, the address and the port, are the default ones, but I'm just putting them for reference. So you can just put HTTP server on and you're good to go. Okay, so here we have nothing, of course, nothing in additional in Prometheus, because Fluent Bit is not exposing the data, but now we are exposing the metrics. So Prometheus should start collecting data from this Fluent Bit instance. Let's give them a few seconds. Yeah. So we start seeing that. So what we're doing is that we are just sending a message to dummy, and then this dummy message we are sending out now to a Splunk server, right? Let's go here. As we see, it's pretty much the same here. Nothing has changed, except that we are now exporting the metrics. So it's a very low number. Let's add a little bit more of flow to this, so we can see bigger numbers. Okay, it's trying to do a graceful shutdown. Should be done already. Cool. Of course, it never failed when I was trying this, and it's failing now, right? Yeah, it's still running. Okay. Sorry for that hiccup. Okay, now we should see here, if we give them a few seconds, we should start seeing bigger numbers in the input. Yeah. And so now that we have a higher rate of records, we could see here that there are issues, right? Here we are comparing the input bytes per second and the output per second. So if you can see here on the right side, we compare records for the input and output, and the input is up and the output is down, completely zero. And we will start seeing retries fail. We should start seeing dropped records, right? So this is going up quite fast because we are not receiving anything, right? Okay, so these are basic tools and the tools that we're going to use during this session to identify back pressure and to identify what happens with our pipeline when we start implement measures to deal with this. Okay, we're just gonna leave it run meanwhile. Okay, so handling back pressure. What are the options that we have to handle back pressure? Again, in general, and then we're going to the Fluent Bit specifics. So we could do a flow control. This basically means that we will have mechanisms in place to communicate back pressure signals between the pipeline components, right? Allowing them to adjust the data rate if they have such a feature. If you are already running high loads of data, you may have encountered with some data endpoints responding with 429, for example. It's saying basically, hey, you're sending data too fast, retry later, right? So this is one of the options that we have. Flow control, identify and correctly handle the signals about back pressure between the components of the pipeline. We have buffering, of course. This is a temporary storage to smooth out the fluctuations in data rates, right? For example, in Fluent Bit, we could add file system storage or other options to do a buffering or to use the buffering, because it could be that you have buffering, but because of the configuration you are using, you are not exactly buffering data to the extent that is allowed by that configuration. The rate limiting, of course, restricting the data of the rate, of the incoming data to prevent this overload. You can throttle the component that is sending data, and hence allowing your pipeline or the component in your pipeline to correctly handle the pressure. Load sharing is another option. This means that you're going to drop the excess data to protect the next component of your pipeline from the collapse, right? So instead of passing all the data that you are collecting, you can send either summarized data or sampled data, or just randomly cut some of it. It depends entirely in your use case. Then, of course, you have scaling. You can increase the capacity of the pipeline components to handle higher data volumes. Out there are some automated commercial solutions, and of course, you have if you're running in Kubernetes, you have the auto-scaling solutions there. Another option is the well-known circuit breaker, where you can stop traffic to systems that are not correctly working, and then resume when the check for the circuit returns what you expect to continue processing data. And of course, asynchronous processing. This will allow for processing to happen when the resources are available again, and not in a synchronous blocking fashion, right? It is not the optimal solution, but could be useful when, for example, sending data to cold storage. So you need to send the data. It doesn't matter if you have some delays higher than expected in a regular pipeline, but you only need to move the data there. So it's something that you could do. Okay, so in order to decide which of these options to use in Fluent Bit, we need to know how Fluent Bit it's reading the data, how Fluent Bit is ingesting the data into your pipeline. A brief overview of how Fluent Bit reads data, some things to keep in mind while trying to deal with the back pressure is that, first of all, chunks are capped at 2 megabytes. Chunks are the basic unit of that Fluent Bit will use for buffering your data, right? There is a soft limit there in the chunk size, but this is how this is handled in Fluent Bit. And Fluent Bit will be appending to chunk based on this not the well-known configurator parameter. We usually recommend to leave it in the default, but if you need to deal with some scenarios when you need to change it, yeah, you can use a buffer chunk size and buffer max size to deal with that. So it means that Fluent Bit will process this amount of data before sending it to a chunk. Okay. All the processing of the data is done in memory. Even though we have file system storage, all the processing will be done in memory. More about that later. We have data serialization. Fluent Bit internally works with message pack, which is a format of for compression of data that is very, very good for compression, but it requires serialization and deserialization when you're dealing with it, right? And another thing to keep in mind that is kind of new, if you have just installed Fluent Bit, configured, and leave it there for a long time already, is that inputs can be threaded, meaning that they can run on their own thread. Okay, so as I said before, chunks are these components where Fluent Bit is going to put your data for further processing during the whole life of the data through the pipeline. They will be the data will be in chunks. Okay, these chunks could either be only memory chunks, which is the default of Fluent Bit when you define. By default, we define that the storage is memory only, or you can have storage file system, which means that it will be a combination of memory and disk. Why is this a combination of it? Because chunk files will be memory mapped files. That means that we will always work in memory. We will put the data in the memory for these chunks, and we'll delegate the writing operations to the kernel. So the kernel will decide when to write to the disk. So once the input reads the data, it will do the first processing if the configuration says so, and then put it into a chunk, which will be available for the rest of the pipeline. For example, then the filters will take the records from these chunks and will start processing. And then when they are ready with the processing, the output plugins will take the data from the chunks and send it to the destination. What options Fluent Bit has to handle sorry. So what are the options that we could use to deal with the back pressure from the data flow and storage perspective? We have member limit, which is basically a limitation on the amount of memory the input plugin can use. This is only for memory storage. And as I said before, it's kind of permissive, or it has a soft limit. Let's say that you have 1.8 megs in a chunk and you need to write another set of data that is, let's say, 500 kilos. So that means that it will be over the 2 megabytes. Fluent Bit will allow this writing of data in the chunk, but the next will not pass. What will happen here as well is that the engine will notify of this, right? The the chunk is over the limit, and this membaf limit is over the limit also. So it will signal uh, the input plugin that it should pause the ingestion of data. It will tell it to do whatever the plugin has defined in this callback, in this post ingestion callback. And once space is freed, then the resume callback of this input plugin will be executed, and will continue ingesting data. We have the retries. By default, Fluent Bit will not retry failed chunks, will retry only once, but you can set this either to a number or to false, which means unlimited. So you will keep trying no matter what happens. And tied to these retries, we have a scheduling mechanism. The default should work for most of the cases, unless you have an scenario where your data endpoint has been out for a while, because this is going to schedule the retries based on a quite basic algorithm, but it is exponential as well. So it could move the next retry very, very far in the future. And we have file system storage, of course. This is what we most recommend when you have a lot of backpressure scenarios. We recommend to use file system storage, which will use these memory mapped files that I mentioned before. No questions? No questions. Okay, let's go back to the hands-on. Yeah, so here we can see that this is not sending data at all, right? And in the logs, we should see all the errors here. So we're going now to try another configuration. And for this configuration, it's basically the same that we had before, but we're going to use the YAML format. I hope it stops by itself now. Let's see. Yeah. Okay, so this is pretty much the same. So now we're gonna run this channel config. Yeah, and connection refused. Right, so the we should see pretty much the same we saw before. This output retrial fails, and these dropped records going up. It should go up really fast. Yeah, not that fast, because I think I changed the dummy rate. No, it's a good one. Yeah, but this number is very high. So this looks like a tiny number, but it's not. As you can see, over 7,000 have been dropped already. So let's start trying to deal with this back pressure. So the current configuration for this dummy, which is the one that is running now, doesn't have any configuration to to deal with the back pressure, right? So there's nothing we could do here. But we're going to introduce one of those here. We're going to add, retry limit. We're going to say 3 times. So we're going to retry it 3 times. Otherwise, we are going to drop it, right? So this should be, yeah, that's better. So we can see how fast this is growing, right? But with the this retry set to 3, we should start seeing a different behavior, right? So we're seeing retrying some seconds, right? Before we were seeing connection refuse, another retries, and then cannot be retried, right? That means that we retried already, we are not doing this again. Now, those messages are not showing up yet because somehow we are dealing with this back pressure from the right side. We're saying, okay, let's not fail immediately, but let's retry 3 times. And so with that, we should see that the growing rate should be smaller, right? This growing rate should be smaller now because we are retrying 3 times. We are not immediately dropping the records. Yeah, so instead of starting going up immediately, this is kind of keeping low because of this retry. Okay, so we are going to enable the output size. We're going to start receiving these records. And we will see a lot of these graphics going up quite fast because Fluent Bit will try to send all the data. So yeah, started already sending data, and this should go up the input numbers now. Yeah. So it will at some point stop dropping records, right? Yeah. So it's stable now because the right side of the pipeline, let's say the vendor that is receiving our data is actually receiving the data now. Okay, 15 minutes. Okay. Okay, let's go to another configuration. We are going to quickly remove the dummy. That was too much, right? Yeah. 1, 2, 3, 4. Yeah, that's better. Okay, we're going to use, instead of the dummy, we're going to use a file. Let's do this. Okay. So as you can see, the log is now overwhelmed with succeeded tries to send the data, right? Okay, let's start this again. Now we are following a file that we are generating here. We are writing logs to that file, and we should start seeing a somehow different rate now. So in the log, we are not seeing any errors because the output server is up and it's receiving data, right? So if we go here, the input and output should be quite similar. So we are good because it is working. But what if our server is not responding anymore? Again, we could start with the retry, right? Set to 3. So it's not failing immediately. It's having some buffer um, to keep data while the output is failing. But what if member limit? What if we add a limit here? Let's say 25 megs. And we also say storage limit. Okay. So as you can see, it was keep trying, right? Maybe up to 3 times after the first try and not doing anything else. But now we're adding a limit to the memory that this point can use. 25 megs. No file system storage. Wasn't shock overlay. So we should have this number. Yeah, we need more load. Yeah, time is flying. We need some more load. Okay. So with more load, we will start seeing that the tail plugin is being paused, right? This is because the capacity of the pipeline is not able to deal with all this amount of data that we're sending. And once it can actually make more space, it will resume the detailing of data, right? Okay, so we're saying this pausing and resuming of the plugin because we put a limit to the memory that it can use. Okay, your system could have a lot of free memory, but that's not the same. We're just saying Fluent Bit to use only this amount of memory for this buffering. Okay, so let's go back and let's enable the storage now. Right, we are gonna keep the retry limit and these two config will not matter now because we will be using file system storage for that. Okay, so we are going to start this again. And we're going to stop the server. So this should start failing, right? As we are seeing now. It's a very high load, right? But we told that we will have storage for our buffering. We will use file system for this. So let's see what we have there in Barlog Fluent Bit. I cannot see that because I have something from Zoom, but yeah, I can barely see here that this has a lot of space use and it's continually growing, right? So it is failing. Let's move the retry limit. Let's say that this is gonna be false because it has reached a limit already. So doing only 3 retries and then dropping. So what we're going to do is to tell Fluent Bit to just keep trying until the server responds. It's not going down now. Let's help it a bit. Let's take a look at the metrics that we have for that meanwhile. So here we have chunks, right? The chunks that were in use by Fluent Bit. A lot of chunks were in use. Let's see the chunks in the file system as well. Chunks, file system chunks, and then file system. Yeah, so this amount of file system chunks were accumulated in the directory that we configure for that. Let's do a, yes, you can see the space is small and now it is starting to grow, right? Because we stopped the server. And we should see 31. We should see something very similar in the file chunks now. Yeah, we have 28, 38. So it is growing. So Fluent Bit is now writing the data that it cannot send to chunk files. And as we said before, these files should be around 2 megs. Okay, this is because of the size of the record. So it doesn't need to grow up to 2 megs. It will put more data in older chunks if needed, but given the size we are using now, it's not necessary. Okay, so these are 2 ways we can start dealing with the back pressure. We are over time already. I just want to mention if we have back pressure inside the pipeline, we could make use of how the filters work now in Fluent Bit. In the old times, Fluent Bit used to have one main thread where the inputs and the filters will run, and now we have a different threading mechanism where the processing. This is the old one. Sorry. So in the main event loop where you run buffering, scheduling, regenes, which is called the engine, right? You will run all the filters, and you have one thread for the input plugins and one for the output plugins. Where's the issue here that if you have a lot of filters, there will be contention there, because you will be doing the work of the filters, and you will be for each filter you will be serializing and deserializing from message pack. So now you can run threaded input plugins, meaning that the processors where you can run like the same filters, you can put them here, where all the processors that you have defined for your input plugin will be run in sequence, and you will not have the overhead of serializing and deserializing. And also it will be running in a different thread. So we have threaded input plugins, the main event loop, and also you can use workers in the output side for the output plugins, right? So you can have more than one thread running there. So we're going to skip the hands-on. We are over the time already. So let's see if there are any questions from the audience. Thanks for staying until now, by the way. Okay, as I said before, you can try Fluent Bit if you don't want to install, if you don't want to spin up a container. We have this in instruct. You can about enabling TLS. Okay, you can scan this QR and you will be directed to the instruct for Fluent Bit 101. It's a very basic one. If you want to have more hands-on labs, you can write us on Slack and ask for that. So Aditya is asking, how about enable TLS? We have observed that enable TLS causes a lot of records being dropped. That's interesting. I would like to take a look into that. If you can report that through GitHub, you can open an issue there. I would like to have a look at that because we haven't seen that. We usually configure TLS. What we omit is the certificate verification sometimes, but we do use TLS and we have a lot of customers using TLS. And it is the first time I hear this, that enabling TLS is causing records being dropped. I would like to take a look into that if you can report an issue through the GitHub, please, Aditya. Okay, any more questions? Sure, you're welcome, Aditya. By the way, we are on Slack, but the best way, if you need help troubleshooting an issue, will be through a GitHub issue. Okay, thanks for being here until this time. I hope you have enjoyed, you have learned something from today's session. And to the next one, I think.
Thank you, everyone.